any steps that are involved with actually plugging in information, if you don't have the LCO thing set up yet, you can go back through and follow through with what I have indicated, and then I'll put this up for you so that you can refer to it. And of course, I'm always available to answer specific questions if you get a snag somewhere and for some reason something isn't working or you're not sure how to interpret something. Okay, so you'll want to use that link, and what that link will do is it will bring up, where it is, it'll bring up this LCO, uh, Las Cumbres Observatory uh, front page. And then we can see what's happening here in terms of the telescopes that we have available to us to take pictures. And so this is why we can get a declination that is below zero, is that we have these telescopes in Australia and in South America and South Africa. And we also, and if you put the pointer on these, it shows you how big each of the telescopes is. And so this gives us an opportunity then to view it either from the northern and the southern hemisphere. But the one thing that we can't do anything about is what is the nighttime part of the sky. And so that's where the right ascension needs to match up as being between 6 and 16. And so then you would go to observers and go to the observing portal. And now I've already, it'll ask
Excuse
you
me.
to log in and do a
Uh,
password. Is everybody okay?
Sorry. I have a question. Is there a way you could share your screen too?
Share my
Sorry.
screen. I was sharing my screen.
Oh, I don't,
Not
for some
working again?
reason, I don't see the screen on the portal for the website for the telescope. I don't see that
Okay.
screen.
Okay. Do you see this?
I see the whiteboard with the information
You're
about
still seeing the
rights.
whiteboard. Okay.
Yeah, and with the office
Thank
hours.
you.
Yeah.
Thank you. Okay. So let's just go back here, go all the way out and then back in. And then, okay. So can everybody see that okay?
Yeah. Yeah, I can
Okay.
see it now.
Okay.
That's where
Thank
I'm
you.
at too.
Thank you. Okay. So where we were then is with the, to keep jumping back and forth between these things, losing my place. There we go. And so now we'll go back one. Okay, so then you'll bring up this screen and this will show your where the telescopes are located. So that's what I was pointing out. You can put your cursor over any of those, and you can find out what the exact details are of what each of the robotic telescopes are. And so this is just a big array. And so then you'll want to go over here to, for observers, observing portal. And then I've already logged in, so it just brings me immediately into this. But what you'll want to do is log on, and you'll need to set up a password. Has anybody had a chance to do that yet? Okay, some of you have, so you could follow along with me if you want, and otherwise, this is what you'll see once you have successfully logged on and given your password. And then once you've done that, a lot of times you won't need to do it again. It'll just take you straight into it, the way that it did for me. One thing that you'll want to do when you use the password is use you're going to want to use the email that the link was sent to. And so don't use a different password. You know, say if you that was your personal email, and then you use a Questa email to try to log in, then that won't connect properly. So it has to be the same email address that that link was sent to. And so that was a mistake that I made when I was first doing this, is I did it using my Yahoo account, and then I tried to log in with my Questa account, and it wasn't configured right because the link was sent to my originally to my Yahoo account. Okay, so once you've been logged in, then you can go to Submit Observation. And you click on that, and then this will give you this is where you basically place your order for the photograph of your binary star system that you will then analyze. And one other thing I wanted to mention too is the quality of the picture oftentimes is influenced by it not being too close to the horizon. And so it's possible that something, say, that is at 6 or 16 would be looking through a little bit more of the atmosphere. And so you might get a little more atmospheric distortion than if you had something that was, say, midway between 6 and 16, like 10. But you can't be too picky because there are so many other constraints on this. And so anything that looks like it'll work for you, that has the right kind of data, I would go for it. Okay, and so here, first we're going to need a name. And so what I did is I went to the team workspace, and I looked for a few uh, potential stars. I found one or two in here that had a right ascension that was not so good. It was like 5 hours, I think, and so that's out of view already. Then I think I checked one of these over here, and it had a difference in magnitude of more than 10. And so those wouldn't work so well. But then I tried this one. It says link 1 that Levi did, and that one looked pretty good. Let's see if I can find that one here. Yeah, then so I'm bringing up Levi's uh, star here, his binary star. And so what we'd want to do then is enter in the name of it. And so you can do that by just going back to the link to this site and just copying that name and pasting it in. So I'll do that, and then I'll go back here to, let's see, submit observation. And then I'll do WDS, and then I'll give it that name, and then I'll give it some initials like JE for my name, just so that I can identify that that's mine. Then in the next one down, this is where you have been cleared to use telescope time with that email that you got today. And so one of your choices, maybe your only choice, would be this Pan-African citizen science. Is that a choice that you have? Anybody following along with me? Are you getting that? When you click on proposal,
Mine says USA Sky Partners, and that's the only one.
okay. Well, then that apparently that's been shifted then to USA Sky Partners. So go ahead and use that one. And that's what everybody should have then, is USA Sky Partners. Is it anybody else gotten to that point and is able to see that? Okay, so you haven't logged on yet and given your password. Okay, so you just can follow along with this then and just select the choice that you have, and that is your funding source for taking the picture. And so you have telescope time allotted to you because of that email link that's been sent to you. And so then we'll go down, and a lot of these things are default values. And so you don't really need to touch any of these until you get down. And here wanted to just point out that the instrument that we're using is a 0.4 meter telescope. But we don't need to change any of those settings. And then we can leave exposure count at 1. And then here, where it says that a valid number is required, you see here where it's saying that in red? For exposure time, I would recommend 2. And so that's 2 minutes. Okay, now you want to be really careful here not to type in the wrong number because you could use up all of our telescope time if you say put a 2000 in there or something. And so this means that the exposure time that is associated with this is going to be 2. And then the filter that we're going to want is the Bessel 5. Okay, so we want an exposure time of 2. We want the Bessel 5. And then up here, you're going to want to select your funding source, which is probably the only one that you'll have available. And then on the top line here, you'll want to give the name of the star, maybe with your initials as an identifier. Is everybody okay so far with that? Have I lost anybody?
Just want to make sure, you only made changes to the instrument configuration, right? So far?
The only thing that I've done is
At the beginning.
I've entered in the exposure time
Yeah, and the
and
exposure.
the Bessel 5. That's it.
Okay,
So
great.
only just put in a 2 and nothing else, please, except for a 2. That should be enough time. If it turns out that that's not enough exposure time, we could expand on that a little bit, but that typically should be enough exposure time. And then this is the filter that we want to use, a Bessel 5. So
Thank
those are the only things except for up here where you enter in the name and then you select um, the funding source for the telescope time. And so then we'll go down here and you'll want to put the name back in again. Okay, so this is your target. And so I'm just going to copy what I wrote up here and put that in as the name. And so that's what will appear when your photo is pending. And I'll show you how that'll look a little later. But I'm just going to copy that and I'm going to paste that down here into this spot. And so then that spot has been filled. We have a name for this thing now. Now, the next thing that we're going to need to do is put in the coordinates for that star. And so this is where you're going to shift back and forth between the Stelladopy info and your LCO telescope. And so what you'll do here is here's your right ascension. And so it's 6 hours. So that's okay. 6 hours is near the edge, but it's fine. 27 minutes, 9.8 seconds. And so you'll want to copy that right ascension, Control C, and then you'll go over here to the telescope and type that in for the right ascension. So you just do paste, Control V. We'll take care of that. But it's not quite in the right form yet. You're going to need to get rid of the hours, minutes, and seconds symbols so that you just have numbers with spaces between them. So I'm deleting the second here. I'm deleting the minute here, but there's still a space between the numbers, so we're okay with that. And I'm deleting the hour here. Okay, so now we're at 6 hours, 27 minutes, and 08.18 seconds. And so that's the right ascension in the right form. Okay, and so remember the right ascension is the first one that is listed. And then the second one is the declination, which is in degrees, minutes, and seconds. So the right ascension is in hours, minutes, and seconds. The declination is in degrees, minutes, and seconds. So once again, I'll go back and now I'm going to copy the declination. That's this one here. And you want the plus sign in there, or if it's minus, it means it's a declination that is below the equator. Okay, but that's okay because we've got telescopes in the southern hemisphere. So it'll just go to one of those if this were a negative value for the declination. So now I'm going to copy that with the plus or the minus sign in there. And then I'm going to go back over here to the LCO and I'm going to paste that in. And so once again, we're going to need to get rid of the hours, minutes, and seconds symbols so that it's just numbers. And so 6.1 seconds, that's the two little lines there is the seconds units. I'm going to delete that. And then I'm going to delete the 1 apostrophe, that's minute symbol there. And then I'm going to delete the degree symbol here. Okay, so now we've got 0, degrees declination, 8 minutes and 6.1 seconds. And then I'll click outside of this and there we go. Okay, so now it's entered in the coordinates and it says here, good news, 118 existing frames that you have access to have been found on the LCO Science Archive covering this RA declination. So that means we got telescope coverage. That's very good. Now we can look up here sometimes what I've seen, and so the duration of the observation request then is in is going to be a little more than 2 minutes, and so that's okay. So that's what the 2 here was representing, is that we're getting 2-minute exposure time for this thing. And so that's how much telescope time we're using up. But if you see something here that says 5 hours and 23 minutes or something, then go back and double check that everything's right and don't do a submit request if this thing is much more than 2 minutes. Okay, because that's really important for our telescope time. I could just order these for you and do all of this, take the pictures for you and send you the files. But I wanted you to, and that's the way that a lot of classes do this, especially at the high school, is they'll basically, you'll find the Stella Doppie, and then your teacher will send in for the pictures, and then you'll get the pictures and you'll analyze them. But I wanted you to be able to go through the entire process, and so that's the reason for setting up an account for each one of you, and then that gives you the opportunity to also, if you wanted to take more data in the future, or if you had other stars that you wanted to look at, or maybe the picture didn't come out, and so you wanted to try a different star, you'd have that kind of flexibility. Okay, so we're getting close now. Now, down here at the bottom, there's something that shows visibility. Isn't anybody gotten this far with me? Is anybody gotten to the point where it says that the existing frames you have access to that are covering this right ascension and declination? Do I have anybody there with me? Okay, so that's what you're going to want to see, though, once you have this thing all set up and are ready to go. And then this tells you when that will be visible on what telescope. Okay, and so this shows that there's a visibility window. It's not a huge visibility window. And the reason for that is that it's at that 6-hour point. And so that 6-hour point is near the edge. And so there's not a lot of visibility, but it looks like we could get a good picture of this. And so then what you would do, and I've already submitted the request earlier for this one, I've already taken a picture of it, is you would just click here where it says submit request, and that's the green submit request button, and you just click on that. And then what it'll do is it'll take you, I'll just go ahead and do it here. I'll click. Can you see that I'm clicking on submit request? Is that showing up for you? When you click on submit request, then it'll say the request will take approximately 2 minutes and 4 seconds of observation time. Are you sure you want to submit this request? And so this is your chance to back out and say, oh, I didn't really want this because it's going to take 4 hours of telescope time instead of the 2 minutes that we want. But once you've clicked on submit request, then that will come up. And then if everything's good, you're good to go with that, then you click OK. And then this is what'll pop up. This will show that your request is pending. And so I've just taken a picture of Levi Star, and the picture is pending, and it gives the submitter, and this was my email when I submitted it. And then it shows the observation time here, and so that is all good. And so then if we go back to the main viewing portal here, we'll see, look, there it is. I just submitted it and it says pending here. Okay, so the fact that it says pending means that we're waiting for it to be completed. Now, I'd done a couple earlier. I actually did the same one earlier. And so this one has already been completed. This was like 2 hours ago that I did this one. So once you bring that up, should be able to double click on that. And then click on data. And then here, let me just move your pictures out of the way so I can see this thing. Oh, look at how nice that is. That looks like a beautiful binary star system. Isn't that nice? You can see the two stars there. And so that looks like a really good picture. So I'm pretty happy with that one. And so we have a file. And if we decided that this was going to work, then next week, what I'll do is show you how to download that file into the analysis program. And so to do that, you would click on the file that you want, and then you would download selected. Okay, and once you've downloaded it, then it turns into a zip file, and then I'll show you how to bring that up in what's called Afterglow. So what we'll do next week is we'll get you set up with Afterglow. Does everyone have a Google account? Because you'll need a Google account to do Afterglow. And so you this week, if you don't, I checked, I think most of you do have a Google account, but if you don't have one, you might want to just set one up. I think that's the easiest way to get into Afterglow, which will be the analysis program. Then once you have these stars in Afterglow, you'll be able to blow this thing up, and then you'll be able to select the primary star and then draw a line to the secondary star and then click again. And then that'll give you the R and the theta value. But because of the fact that there's a lot of atmospheric distortion, that can cause the position of the stars to vary a little bit, just because of the differences in the air conditions at the moment that the picture is being taken. And so what we'll do is take 10 pictures, and then that'll average out any atmospheric distortions. And then you'll do 10 measurements of the R and the theta values. Then we do a statistical analysis, and we write up the results for publication. And so that's the process. And so we're to the point now where hopefully you're getting closer to being able to select your primary binary star system, the one that you think is going to work the best, and maybe have a backup. If you could put those on to your team workspace here, then I can check them and I can look at them and help you with them. And so this one here, I've already taken a picture of this one for Levi, and you might want to just go ahead and take another picture of it, Levi. But then once it is brought up, I think you should be able to have access to it. Once it says completed, should be able to click on it and see it, even though it's my file. And then you can download it, and then next week we'll start looking at Afterglow. So if any of you want to talk to me as a team, uh, I'd be glad to look at any of your stars either now or between now and next week. You could come by on Monday during my Zoom office hour then, and we could look at them at that point, or I could schedule a Zoom conference with the individual people in the team. Whatever would work best for you is fine for me. So that's pretty much all I wanted to do today, unless somebody wants to ask me about any of the questions that you've accumulated, or if you want my opinion on a binary star system that you've selected. I could look at that with you for the remainder of the time, but that was all that I had scheduled for today in this group meeting. Are there any questions? Does it seem doable? Yes, it seems like you're able to find a star and then take a picture of it. Okay,
I have
well,
a question.
yes,
These videos that are being recorded, are they posted on the homepage as well?
yes. Yeah, I've been
Okay,
putting
thank
them on
you.
the homepage. And so it takes a couple of hours for this video to process, but then as soon as it's processed, I'll put it right on the homepage, and it's there right above Unit 1, Unit 2. Most of the lectures are there. One of them didn't work out, and so I wasn't able to get one of them a few weeks ago, but almost all the lectures are there. Yes.
The last week's, I think it hasn't been posted yet.
I posted that last last Thursday, or yeah, I posted it Thursday night. It's showing up on mine. You might want to double check. I'm pretty sure that's up. I also looked at it on another computer just to make sure that it wasn't only working on my computer, but I posted that a week ago.
Is that the number 5? Like I have them through number 5, I think. I thought that
One of them didn't go through,
that
but
was
the
4.
last one,
That number, the last one would have been 6, number 6. So I
yeah.
don't.
Yeah, you're only seeing 5, I think, because oh, the one from last week. Oh. Yeah, last week's I forgot to record the one last week. Yeah, sorry about that.
Okay. At least I know I'm not going crazy.
I think that the main things that we were looking at last week were just kind of a reiteration of what we had done the week before in terms of how to enter the information into Stelladopy. And
Yeah.
then last week I think I just kind of went through some of the specifics of things that we're looking for on
I was looking to see what or confirm, like you set up individual group what do you call it, the spreadsheets,
the teams. Yeah,
wanted to confirm like what kind of information you wanted us to put on that, or is that just
you could either put it on the teams one, or if you are, I'm not aware that anyone was using that space yet. But I made
put
that
the same
available
information on it,
I
just
made
to
that
start with.
available for you in case you wanted it. If
So it's just like anything, any information we gather, is there anything that we should
my
put on, or just
my hope was that here's our team workspace. Let's say you were in team 1. Okay, so you put
I
some things
added
in.
that
Oh,
just
I
to
see. So
repeat.
so you put it in. Very good. So I can check these. Okay, I didn't realize that you
Those-
were starting to use this yet.
yeah.
So that's fantastic. Good. I can look at those and give you some feedback if you'd like.
I think Ave talked to you in class and.
You're right. Ave
yeah.
was
And-
mentioning that one of your prime candidates had a right ascension of 5.
Right, and so, yeah,
And so that went out of view. I looked at that one, I go, oh shoot, it's out of view. And then I realized it had been like 2 weeks since we'd been talking about it, and that's about how long it takes if something's right on the edge of the viewing to go out of view.
so that's one of the stars there, and then the other one I think and Amelia had looked at it was he discussed that one with you too, and it was I think the separation or
Yeah. Let
It
me just
wasn't big
pull out.
enough
Is that
for-
this one
yeah.
here?
That one also had a weird right ascension value. Right, it was in the
Yeah,
5-hour range.
So oh yeah, that's in the 5-hour range. So that's going to be out of view. Let's go back. And then this one, is that one also in the 5-hour range?
Yeah, I think.
Yeah, they're both. What luck? Both in the 5-hour.
They were so good.
They were just barely in range a couple of weeks ago, and now they're no longer in range.
So basically, there's not much to discuss right now. We just need to get a new star. So,
Okay, well, what about those secondary stars that you were
Oh, that wasn't a secondary. I just put additional information. It was a photograph or an image. So
okay.
that was
Now,
that second column.
if it gets too hard to find something, I can give you a shorter list. But the problem with that shorter list of candidates is that it's been overstudied, and that there have been a lot of high school students that have gone through and have already selected those. And so the publishability might be questionable, but you could still get the full experience of doing it. I was just hoping to get ones that would give us fresh data so that they.
I think we like the challenge of finding a good one.
Okay, good.
To get that filter is that we use is powerful. We just need to figure out how much to how much we want to filter it down.
Right.
But
Yeah,
we
there's always the possibility that you could go with something that was observed since 2015, like say up to 2020, that hasn't been overstudied. That would give you other selections too. If you found one that only had say 7 observations, you could relax that constraint, and I think a lot of new ones have popped up between 2015 and 2020. But that's what Rachel had suggested, and that's the way that she's been teaching the class to kind of ensure that there's a little bit of a gap between the last observation and the last published data point and the one that we'd be contributing, so that we're not just putting them right on top of each other.
Right. Yeah, I think that we'll just go back to the drawing board. Ave is not in this meeting today. Said he was going to miss it, but I think we just need to kind of make sure he's included in these decisions. So
right.
We'll talk to him when he's available, and I'm sure we can come up with a good star. So,
Okay, good.
We're good.
How are the other teams doing?
Right.
I saw that the team 3 had that one good looking star. I didn't look at the other one, but is team 2 and team 3 how are things looking for you guys?
I'm in team 2, and I just put some new stars, and I was wondering if you could go over them and maybe see if
Sure.
any of them were good.
Did you put it in the team 2 worksheet?
No, I put it in the team workspace.
Okay,
I just put it in.
that's okay. That's fine.
Just copied and pasted it from I have an open docs. or note page.
Okay. Huh. Oh, that was, okay, that was team one. Let me just go back here again. And go to the regular Teams workspace. Okay, so is this the one here?
No, sorry, I'm Alana Hess. It's I just deleted one.
Okay, where's yours? Down here?
Yeah, those I just put a few. I just put like 3 or 4 down there right now that I found a few days ago.
Okay.
I just
So,
want to make sure I'm like in the right range.
okay, well, let's take a look at this one. Okay, so we have the principal angle has a good amount of change in it. It's gone from 85 to 66 between 1852 and 2021. And that was the date it was last observed. And it looks like the angle is still changing. We're estimating that it's changed a little from 66 to 62 in the last observation. So that there's a perfect example of where loosening that constraint on 2015 may have paid off for you. And so here we've got a separation that looks like it's changed a little. And we've got the principal angle has changed a fair amount. The magnitudes, the difference in magnitude. Oh, now here we have a serious problem. This
I don't think this
a
one's
magnitude
mine.
difference of 9.91.
Mine's I think underneath this one.
Okay, let's go back.
Sorry. The one with the purple box around
This
it.
one here?
Yeah, and I put a few more to the side of it.
Okay. Principal angle 16. Though that hasn't changed very much from 1924. There's only one observation. I would be concerned
I'm
because there's
sorry.
only one
I think I
observation.
must have put that one in there by accident. If you
I'd be
go
concerned that there's only one observation.
yeah, I don't think I meant to put that one in there, my bad. If you go over to the right a little bit, I have 3 other ones.
Okay. All right. So this one, principal angle 243, it's gone down to 241. That's a relatively modest change in 100, more than 100 years. The separation has changed a little. So this is a possibility. It's changed by 2 degrees over 120 years. And they're estimating that it will be about the same now as it was before. And I always hope for a little more change in the principal angle, because if that principal angle doesn't change much, then you pretty much have the same point plotted on top of the last point. So I'm not saying that we would want to necessarily throw that one out, but ideally I'd be looking for a slightly bigger change in angle over that length of time. And if it's only changed by 2 degrees in 120 years, then in 30 years, it's only going to have changed by maybe a fraction of a degree from that. And so that would add the fact that the last observation was in 1999 means that you'd get a fresh data point. And so that one, I can see that might be a possibility. Let's look at the magnitude differences. They're very similar in magnitude. And so that means that they're probably pretty photographable. Their distance, you see here, because the separation distance is 9 arc seconds, that's why it has such a long period. The farther apart they are, the longer it takes for them to go around each other. And so that's why they don't move very far with a larger separation. But that's a possibility. And it says here, the nature of the double is uncertain. We look at the secondary and primary motions, and we're seeing a little bit of a difference here in the primary and secondary motion, right ascension, and declination. And so this is how fast they're moving relative to each other. And so this one looks like it's moving at a little different speed than that one. So that could indicate that they're not a physical double. But that's something that we could look at more carefully with Gaia. Gaia can give us more updated information, but if they're both moving at the same speed through the sky, then that's an indication that they're gravitationally bound. But if they're moving at different speeds, it could indicate that they're getting farther apart from each other. And so that would be something to consider if you wanted a physical double. Should I go to this one too?
Yeah, you can click on that one if you like.
Okay, so here we've got 11 observations. That's a good number of observations. 1836, good, to 2015. It's going from 257 to 261. That's a reasonable change. Separation has changed by a fair amount. That's interesting that the separation has changed. Okay, so that's the separation between them has changed by that amount. The magnitude of the primary and the secondary are fairly close to each other. And so this one is also uncertain because the motions, well, this motion is close to that one. So it is possible that these two are physically bound. So that would be a possibility. I could if you wanted to take a picture of that one, and I could take that along with this information, and I could take a look at it in more detail. You know, that might be worth a photograph.
Okay. I probably will go to your office hours next Monday too. Because yeah, I'll probably try to collect some more points just in case,
Okay.
you know what I
Okay.
mean?
So the Zoom or my office hour at Cuesta?
Oh, probably on Zoom. Is that okay?
Okay, that'd be fine. Good. Great. Yeah, well, you're doing some good searching, and those both look like possibilities.
Yeah, and also I have a question. So you're saying that like the primary motion and secondary motion, when they are around the same number, that means that it is
That
a
they're moving together as a bound system.
okay,
And
got
they're
you.
moving across the sky pretty much the same rate. They might have a little bit of relative motion with respect to each other, but the motion of both of them together is similar. And if one of them is moving a lot faster or slower than the other one, then it could mean that they're not really gravitationally bound and that they just look like they're close to each other.
Got it. Okay.
Another thing that we could check with that too, if we go to Gaia, and this is something we can do before we start taking a lot of pictures. I could show you how to go to Gaia. You can check and see what the parallax is. If they're both at about the same distance away, then that would be good evidence that it's a real binary, a real physical binary.
Thank you. Okay.
Okay, sure. Anybody else want me to look at anything while we're here?
I had a question. When it says that the nature of the double is uncertain, what information is it lacking? Like when that they don't know if it is or not.
Well,
what I mean?
here, let me move these pictures around so I can go back to the whiteboard. Okay. So, whoops, what happened there? That isn't what I wanted. Go back to the whiteboard. Let's try that again. There. Okay. So if we, whoops, didn't want that. If we have the motion along a curved path like this, say this is our first angle to there, and this is our second angle to there. So this would be like our primary angle, say in 1836, and this is our primary angle in 2015. Then when you plot this up, you're going to expect some kind of a curved path. And so there may not be enough information to see whether that path is curved or not. If you take too small of a section, it could look like a straight path, and it would be difficult to fit any ellipse into a straight path. But if the 2 points are just wandering away from each other along a straight line, then that would indicate that they're not a physical binary, and that one of them's moving at a different speed, is probably also at a different distance than the other one. And so you'd expect the points to plot along a straight line rather than a curved line. And so when it's uncertain, it means that there's probably not enough data to plot enough points to have enough confidence that you're plotting a curved line. And then there could be other factors too, like the parallax. If the distances between the two stars using the parallax data is significantly different, then that would be pretty strong evidence that they're not a physical binary. And if they're, whoops, here we go again. Get that out of the way. And then if this one's moving this way and this one's moving that way, then they're just getting farther apart from each other. And so that would tend to plot out in terms of the separation distance as more of a straight line. And so we're trying to determine, if it's uncertain, whether it's actually doing a curved path or it's doing a straight line. And we're also not sure, because there can be errors in these distances too. And so if the distances are somewhat close, using the Gaia data, then that could be an indication that we're just not quite sure. It might be, it might not be.
So have you seen any in the observations over time, have you seen any go from unknown to known? Like, is it just a matter of
Yes, your data point could be the deciding factor. Eventually they go through and they feel like they have enough data to make that determination.
Perfect.
Yeah, and so each observation has to be a published data point. So it's not just people looking at it and taking a picture of it. They've actually have written it up and they've gotten a publication for it, and then that counts as an observation. Because otherwise, without the statistical analysis, you can't be sure that they did it right.
Okay, that's kind of what I thought so, but thanks for confirming it. Thank you
Sure.
for that.
No problem. Any other questions? Okay, well, if you want to load in more more of the coordinates of binary stars into your workspace, and you give me a heads up that you'd like me to look at them, you can just shoot me an email, say, hey, I've got something going here. You could even just copy the link into the email, and then I could just click right on the link and pull it right up, and I could look at it and then give you my opinion. or you can wait and we can do it together in a Zoom meeting. Okay, well, if that's any other questions? All right, well, have a great week then, and happy Leap Day. We'll get another one of these for 4 years. So I'll see you soon.
Thank you. Bye. Happy Leap Day.
Thanks. You too.
Yay, happy leap day. I also want to say, so like as we were doing that, and I realized all the stars we got weren't gonna work. I went through and expanded the range to 2018 and updated the right ascension to 717. And I found some I found like 5 new ones that I just kind of skimmed through.
Okay.
They're on the Team 1 worksheet thing. And I was wondering if we could look at those super quick, or at least one of them, because
On the Team 1 worksheet?
yeah.
Sure.
Okay, awesome. Because I know that one of my stars had an issue aside from the right ascension thing with like the rho and theta values, but I wasn't exactly sure what. So if you could like explain that to me, that would be sick.
Sure. Nothing just happened here. Below the point where I can, there we go. Pull it back up. And you can see this okay?
Yes.
Okay. So, am I going to your workspace or the group workspace?
Ours, just
Okay.
group 1.
It's group 1. Okay. Okay, and so are these the new ones here down below?
Yeah, I just grabbed those, and so I'm not like everything in them seemed fine. I'm just not sure how to analyze the rho and theta values.
Okay, well this is the primary angle before and after. So that's got a fairly good change. So that looks good over from 1910 to 2018. And then it would be a little higher value. I always like it when I can see that it's a slightly different value than the one from the last observation, because then you're not just plotting them on top of each other. Your separation has gone from 5 to 6, and so that is an indication that there's some movement going on in that one. That could be okay. And then we've got a primary and secondary magnitude between 9 and 11, so that's not a huge difference in magnitude. That's one of the best ones that I've seen. Now here we don't have any information about the secondary star's motion, but that's something that we could probably get from Gaia if you wanted to be sure, and this is uncertain. So if you wanted to put your money on something where you were a little more certain, we could do that. We could go to Gaia and we could check this out and see what those parallax values in the primary and secondary motions and how they match up. But at first glance, that looks pretty good.
Okay. I want to do one that's an uncertain double because I think it'd be more interesting to find out, hopefully, whether it is a double or not.
Sure.
Yeah.
Yeah. So that looks good. Shall I
Okay.
look at another one?
Decent one. Yeah. Sure. Do the next one.
Look at the next one.
Yeah.
Okay, this one, 1806. We only have, well, 8 observations. That could be all right. PA 45 to 48. And then this is about the same. It was last observed in 2018. Separation 6.7 went to 6.4. So that's reasonable. The last one might be a little stronger. The primary and secondary look a little dim. Usually we're going for a primary magnitude between 9 and 11.
Okay.
So I don't know what you set for your parameters, but this looks like
think I set
Might be a
parameters
little
wrong.
dim for the primary.
I just said the delta magnitude has to be like under 4, I think.
Okay, but you didn't set the primary magnitude.
No.
Yeah, I would set that to maybe between 9 and 11. That's gonna make it a little more a little less choices, but that's when we tend to get our best pictures. Is what the reason why we're setting it for that. We don't want them to get overexposed, but we also want them to show up, and so that for the size telescope that we're using, that tends to be a good range of magnitudes for the primary, and then the secondary not to be any less than that. And so let's look at your third one here. And so it's oh goodness, 110 to 34. That's 1905 to 2018. That's amazing. That it's changed.
So what does, I keep getting confused. What's the PA mean?
That's the principal angle. And so the angle has changed. So you want a good picture of what this looks like. Your principal angle is this angle here measured from the north. And so we're going around this way. And so this is where, because you've got an R value. This is your R value. That's how far that's the rho. That's the distance between the stars, and your difference in theta is the difference between this angle and this angle. And so if you've got a good difference in the angle, then what that's showing is that it's going through a bigger portion of its ellipse, which is good because then you can fit the data to an ellipse and you can determine whether it's got a nice curved path or not.
Okay. So big differences in that are good.
They can be, yes, yes, because it shows that you're getting new information and you can plot out more of the orbit. If those differences are very small, then you're barely getting the smallest little slice of the ellipse. And so that means you can't really extrapolate it and see what the overall ellipse would look like. Go to this one, 88 to 85.
Oh, the camera got stuck on the whiteboard again.
Oh, right.
I hate Zoom.
Right. Okay. So we got it from 88 to 80. Is that 85?
95.
95. 88 to 95. And we think that it's at, is that right? 80. How does it go from 88 to 95 and then go back and then stay at 95? Huh. Now this, I guess it's because it was recent, and this is in 1906. So your separation has changed a little bit. Principal angle has changed.
I see the primary is pretty dim also.
Okay. Yeah. So yeah, we want to. I think it is good. You know, we get more star choices, but if we don't get a picture of it, then it's not going to help us.
Yes.
I think that first one though looked like that one had a, what was that first one again in terms of its primary magnitude?
Great. I don't remember. The other one.
Okay, so primary magnitude is 9.7. Yeah, so that's right in the range we're looking for. Secondary, pretty decent. This one, I think it's a possibility.
And the third one,
And that's at 7 hours, so it should still be fine for a couple of weeks, I think.
yeah.
Yeah. Okay.
The third one I'm interested in now, knowing the angle thing. What do you think of the third one?
Well, we looked at the third one. Wasn't that had a different magnitude?
Oh, I thought that was a different one.
I
Wait,
think that the third and the fourth ones had magnitudes that weren't good.
oh, okay.
I think this
This,
one looks the best. I think the second one was still okay with the magnitude, but you know, when you loosen those constraints, you have to be careful that it's not going to take a good picture.
I didn't loosen that one on purpose. Actually, I just forgot to enter that.
Okay, yeah. So
Uh,
you just do a 9, 11, and then make sure that the descriptor says between.
Yeah. Just make sure. So, primary angle first and last on this one are still okay.
Yeah, yeah, I think so.
Okay.
Yeah.
I mean, they're not as impressive as the other one, but
Yeah, yeah. But it's and that was at 2018. So yeah. But there aren't that many observations, which is kind of interesting. So that can kind of mitigate the fact that the most recent observation was recent, that there aren't that many. So, I mean, you can add more when your observation is one of a fewer number.
all right.
Right.
So one more thing. How do I use Gaia to find out more about these stars?
If you want to go farther into it, let me see here. It gives you some information about Gaia. Let me see here. If you click on this link, it brings up kind of a whole.
Brain's not sharing again. I have this solar system mobile thing from like when I was little up in my room, and it's still here. It doesn't work anymore though. But I think it's funny that you can always see it in the background.
Okay. Yeah. See. There you are. Okay. So now let's share the screen again.
Okay, it's working.
Okay. And now go to this thing. Link to programs. It's right above the Unit 1. You can click on that, and it takes you through a whole course that I went through. And if you want to work ahead, you go down here to there's still a DOPI, Naval Observer. Oh, here's Gaia. Okay. So you just go way down here, and then you can click on Gaia. And there's a Gaia tutorial here. So if you want to work ahead and do that, and then if you have a question about it, I can try to help you.
Okay, cool. Yeah, all right.
Okay.
Thanks.
All right. I'll see you next time.
You too. Bye.
Bye.